And today we're going to start with engine classifications. So I'm going to outline 3 different types of engines, and we're going to talk about the one that we're going to focus on the most. But I do want you to know there is more than one type of engine out there. You may encounter any of these types of engines, and you may be working on any of these types of engines. But for automotive purposes, when we're talking about passenger cars and trucks, there's one that we're going to primarily focus on. Okay, so we'll start over here. You may have heard of some of these before. Okay, we've got a 2-stroke engine. A 2-stroke engine is common in power sports. So you've got dirt bikes that are 2 strokes. You've got things like rototillers, lawn and farm equipment that are still 2-stroke. Weed eaters are 2-stroke. So there's plenty of that stuff out there that does need maintenance and does need work, but it's not something that you're going to have millions of on the road compared to what a car is. So 2-stroke engines operate using a lot of the same components, but the way or the concept that it works is a little bit different. So we're going to talk about each one of these and outline some of the differences. Next, you've got 4-stroke. This is the one that we're going to focus on. We'll put a star beside that. The 4-stroke cycle is the most common type of engine out there. Both gasoline and diesel, even some propane or natural gas vehicles, use this same concept. It uses some of the same components and parts as a 2-stroke engine, but the way that it combusts the fuel and air, and the way that it pulls in the fuel and air is a little bit different. And then over here, we'll put one of the least common types. That is a rotary engine. There are very few manufacturers using that. One of them is Mazda. Mazda came out with the RX-7 back in the 80s, and it didn't go over very well. And then they came back out with it again in the 90s, and it still didn't go over very well. So then they came out with the RX-8, and it was about the same result. They're fairly nice cars, but the engines just do not last. The way that it's designed, it doesn't hold up to the demand of driving 200,000 miles like a traditional 4-stroke engine does. Okay, so now we're going to outline some of the differences here. So these 2 things, like I said, or these 2 engines, are going to share a lot of components. So we have a crankshaft for both of these. We have pistons and rods, connecting rods. Now, a rotary engine, it doesn't have those things. A rotary engine has what's called an apex. So it does not have nearly as many rotating components, which is kind of a good thing. It's much smaller, it's much lighter, but again, it doesn't hold up very long to the demand of people wanting to buy a car and keep it for 20 years. Okay, so we'll just talk about these 2 things first. The crankshaft is the component that continuously rotates inside of a block or a housing, commonly referred to as an engine block. We're going to be talking about all this stuff in depth when we disassemble these engines, and you'll see there's bearings that support these crankshafts, but just to keep it simple, when you start your car, when you hit the key to start it, the starter jumps out, it gets a hold of the flywheel, and it starts the process of rotating or spinning that crankshaft. The crankshaft, depending on how many cylinders it has, is going to have at least one rod and piston combination that is bolted or connected to that crankshaft. So the crankshaft has what's called a journal, and it's offset. So the crankshaft will have a center line, and then it will have a journal that's off the center line. So as the crankshaft rotates, it is moving that piston and rod combination up and down, up and down, up and down inside the cylinder. Okay, so we have cylinders. And again, most cars, all cars, are either going to be 4, 6, or 8 cylinder. But just to keep it simple, you could also have a single cylinder engine, like a motorcycle, for instance, or a lawnmower that is following the same basic principles. So this piston is moving up and down, up and down, up and down continuously, and is rated usually in RPMs or revolutions per minute. So obviously, the more pistons you have moving up and down, the more power you're capable of generating with the engine. So traditionally, 4, 6, and 8 cylinders are common, but they do make 10 cylinders, 12 cylinders, 16 cylinders. So there's not really a limit to the number of cylinders you can have, but the more you have, the bigger it gets. In a typical passenger car, 4, 6, and 8 is common. There are some 10 cylinders out there. There are some 12 cylinders. Very few 16 cylinder cars, but there are some. Okay, then we have cylinder heads. And this is where things start to get a little bit different. Okay, so on a 4-stroke engine and on a 2-stroke engine, these things for the most part are the same. But once you get into the cylinder head, that's where things start to change a little bit. All 3 of these engines have to have the ability to take in air and fuel and combust them or burn them. Now, the way that they do it is different. So, we have a cylinder head. Notice that I'm not writing anything over here because it doesn't really have a cylinder head. Now, in parentheses, I'm going to write contains valves. Over here, I'm not going to write that. Because it doesn't. In a 2-stroke engine, it has what's referred to as a reed valve. And that is where it pulls in the air and fuel. It also has a hole in the cylinder for the exhaust to go out of. So, 2-stroke engines, this is where the similarities stop. On a 2-stroke engine, it pulls in air and fuel every single revolution, and it burns it every single revolution. That's why it's called a 2-stroke. It simply goes up and down, and it burns that combustion every single time that it happens. So 2-strokes typically don't have a super long life. Dirt bikes, for instance, you have to do a lot of maintenance on them in order to keep the top end of the engine lubricated. It requires mixing the fuel and the gasoline together. So there have been some experiments with some 2-stroke cars, but for a number of reasons, they just don't exist. Reason number 1 being they don't last. You could never get a 2-stroke car to make it, 200,000 miles. Most 2-stroke stuff is air-cooled. The second reason is that it would never meet the emission standards of today's economy. You're mixing oil and fuel together, so the combustion process is a lot dirtier. Typically, 2-stroke dirt bikes, for instance, they smoke. So a car, imagine millions of cars on the road doing that. So 2-stroke engines, this is where the similarities cease. They're no longer similar. They don't have a valve train per se, so they don't have valve springs, they don't have valves that open and close. 2-stroke engines don't have timing components like a 4-stroke engine does. Okay, so since our cylinder head here contains valves, we have to have a way to open and close those valves. So that's where we get into camshafts, lifters, push rods, rocker arms, valve springs, all that stuff. And it all has to be in time. And then over here, it's totally different. It has an apex, which is the shape of a triangle, that constantly rotates, and it doesn't necessarily have a cylinder head. It has a combustion chamber area, but it doesn't have a head that bolts on. Okay, so 4-stroke engines, most common. Diesel engines and gasoline engines operate on the same principles. They do have a few differences. For instance, diesels don't use spark plugs. Gasoline engines do. But when we get into the details of how engines work, you'll see that diesels don't need spark plugs because of the way that they're designed and the way that the fuels work. Okay, so we've got, we'll just say valve train components because there's a whole list of them. And there's different configurations as well. So you've got older engines that have a camshaft housed in the block, and then it will have a small timing chain and lifters and push rods. A lot of modern engines don't have that stuff. They have what's called an overhead cam design, where the camshaft is housed on the top of the engine and the cylinder head. So it eliminates the need for push rods, and most of the time lifters as well. All right, and then along with this, there's typically going to be a cooling system. So this does have a cooling system. All right, two-strokes typically don't. Most of your two-stroke stuff is air-cooled. So if you let it run for a long period of time, it's going to get real hot. The cooling system's job is to take all the heat away from the combustion process and get rid of it, so that we can have this taking place for a long duration of time. Okay, so I'll leave this up here for just a minute. You don't have to write down every single piece of information up here, but it will help you in the future, especially in what I'm going to put up here next. We're going to talk about the four-stroke cycle. So it's called the four-stroke cycle because it has 4 movements of that piston, and each one of those movements does something different. Whereas with a two-stroke, it's doing the same thing every single time. The four-stroke cycle is one of the most essential things that you need to learn, because when you are trying to diagnose an engine concern, you need to be able to kind of play it through your mind as to how the engine works. That way you can narrow down what the problems are. If an engine has a misfire, what that means is that it's not producing combustion, it's not producing power on one or more cylinders. So if you have a 4-cylinder with a misfire, you got 3 cylinders doing work, 1 cylinder doing nothing. There's a number of things that can cause that. In order to fully understand it, you have to first understand how it's supposed to work. Once you understand how it's supposed to work, then you can figure out what's missing from this equation and figure out why it's not working. So is it missing one thing versus another versus another? And if it is missing that, what could cause it to happen? Alright, so you've got this piston. The piston looks something like this. Okay, as the bottom, it's known as the skirt. Got a hole in it, and you've got a series of rings, and then you've got your rod that's going to connect to the piston. It's going to go down, and it's going to have a big end. So we got a big end and a little end. The little end next to the piston, the big end connects to your crankshaft, and it's usually split. Okay, so this piston travels constantly up and down, and it does 4 different things in a 4-stroke engine. Okay, so we got our piston, got our rod bolts with the crankshaft, and the crankshaft is offset, so it's constantly going up and down. All right, so the first stroke, the very first stroke of the 4-stroke cycle, if you have a single-cylinder engine, then you have 1 piston that is going to start on the intake stroke. Now, if you have an 8-cylinder engine, typically you'll have two cylinders at a time doing the same functions. So you'll have two cylinders doing one thing, and then you'll have another two cylinders doing that, and then another two cylinders doing that. Okay? So the first stroke is known as the intake stroke. All right? Now, what is it that you put into your car when you go to the station to fill it up? What fuel do you typically put in a car? Gasoline. It can be diesel fuel, but this is a automotive class, so we're going to talk about gasoline. You fill your car up full of gas. Okay? So, on the top of this piston, you have your cylinder head. So here is the top of our engine block. So right now the piston is at the top of its travel, and we have two valves. So I'll draw one here in blue. Our valves are typically going to be on an angle. So we've got one valve here, and this is our intake valve. Then we're also going to have an exhaust valve. And some engines have 4 valves per cylinder. Some of them just have 2. There's a handful that have 3. Okay? In order for combustion to occur, you have to have a fuel source. Okay? So gasoline is what we use for our fuel source in an automobile. We also have to have oxygen. In order for a fire to burn, you have to have fuel, you have to have oxygen, and then what's the third element? Starts with an H. What? No, that's a gas. You have to have heat. Okay, so in any fire situation, you have to have fuel, which is going to be gasoline. We have to have oxygen, which is in the atmosphere. And then we have to have a heat source. All right, so our intake stroke. The piston is going to be traveling down. Okay, so piston is going to be traveling down. All right, now let's talk about a couple of different terms that are used in association with engine. Engines typically produce cylinder pressure. All right, so these rings, their job is to seal against the cylinder wall. So if you have pressure, you also are going to have the opposite of that. What is the opposite of pressure? It starts with a V. Okay, how do you drink a drink with a straw? How do you get the liquid from the cup through the straw into your mouth? Yes, that's correct. So you are creating a suction, right? It's also known as a vacuum. Anytime you can create pressure, typically you can also create a suction or a vacuum. So as this piston is traveling down, these rings are going to be sealed against the cylinder wall. This valve is going to begin to open. And that is going to create a low pressure area, which is a suction. All right, so in your body, your lungs create that. This engine is doing essentially the same thing. All right, so on this side of the intake valve, what we have is we have a little bit of fuel mixed with a whole lot of air. Just waiting. All right, so it's atomized. Little droplets of fuel and molecules of air. So as the piston travels down, the intake valve opens. And that's going to be controlled by a number of things, whether it's a push rod or whether it's acted on directly with the camshaft. All right, so as that piston is traveling down and that valve opens, we create that low pressure area, which is a suction or a vacuum. which means that we are going to suck in that air and fuel mixture. All right, and that's our intake stroke. So now the piston is going to travel down. Now when the piston gets all the way to the bottom of its travel, it's going to come back up. So the next stroke is going to be called the compression stroke. Now, the compression stroke is very important. On the compression stroke, our piston is going to be traveling up. Okay? And during that compression stroke, that intake valve, it's going to close. So it is going to seal up that cylinder. We no longer have a low pressure area. Both of these valves are going to be closed. These rings are sealing against the cylinder wall. So, I said just a minute ago, in order to have a fire, in order to have combustion, you have to have fuel, you have to have air. So right now, both of those are present in the cylinder because we sucked them in. The third thing that you have to have is some heat. Okay, so compression stroke, piston travels up. Both valves are closed. All right, now, if you take your hands and put them together and rub them, what happens to them? They get warm because you're creating friction, right? You're doing something similar in this cylinder right now. So as the piston comes up, we have all this pressure that is being generated. These rings are sealing. The piston is traveling up. We are generating what's known as cylinder pressure. And that cylinder pressure is going to put the squeeze on that air-fuel mixture. And it's going to make it angry. Okay, so cylinder pressure. Heats up the air. A/F is air fuel. The air fuel mixture. Okay, now something else important has to happen. On a gasoline engine, we have what's known as spark plugs. So once this piston gets close to the very top of its travel, that spark plug is going to fire. And the combination of that tiny spark in conjunction with the extreme heat that is generated from the cylinder pressure, that's going to cause our ignition event to occur. So when that piston nears the top of its travel, we're going to have an explosion. All right. Now this is where things get exciting. The next stroke is our power stroke. Okay, so what we've just done is we've created a controlled explosion. When that ignition event occurs, gasoline is extremely volatile, which means it's explosive. It doesn't just catch on fire, it blows stuff up. So we have at the top of the travel of this piston, right up in this area, we've created a massive amount of energy by creating that explosion. So what is that going to do to the piston? If the piston is up, what must it do next? It's going to go down, and it's going to go down with authority. It's going down with a lot of pressure and a lot of power. Okay? So, piston travels down rapidly. We'll put 2 arrows up here. It's going down quick. And when it does that, it's taking that crankshaft and it's turning it really fast. Alright? So imagine this happening on 8 cylinders. Really, really fast. You're generating a ton of force, rotational torque on that crankshaft. So this is where the power your engine generates comes from. Alright? Power stroke. Piston travels down rapidly. So understand the difference here is on the intake stroke, we are just mechanically turning that crankshaft with the starter motor. On the power stroke, we are forcibly turning that crankshaft under the controlled explosion of that ignition event. Now, we have one last thing that we must do. So this is 3 strokes. The 4th stroke is going to be referred to as the exhaust stroke. During the exhaust stroke, we're going to go on this side. Piston starts to come up. Now, how many of you have ever burned something? Ever started a fire? At a bonfire. Okay? In a bonfire, your fuel is typically wood, right? So at the end of the fire, what's left? Coals and ashes, right? The laws of physics state very plainly that you cannot completely, consume anything. So there's always going to be a byproduct of the combustion process. With wood, you're talking about ash or coals, probably a little bit of smoke. Gasoline's no different. So we are going to take in this much air and fuel. After we have our combustion process, we're still going to have a little bit left. So inside of that cylinder, there are still a few faint remnants of spent exhaust gases. Now, before we can take in another dose of fresh air and fuel, we have to be able to get what's left in the cylinder out. So the exhaust stroke piston travels up. The exhaust valve is going to open. Okay, and that's something we should probably add. To power stroke, both valves are closed. All right, so on the exhaust stroke, piston travels up, exhaust valve opens, pushing out spent exhaust gases. What's left over from the combustion process. And we repeat this process hundreds of times, thousands of times per minute. As the engine speed increases, so do all these moving parts. Okay, so the 4-stroke cycle: intake, compression, power, exhaust. It can also be thought of as suck, squeeze, bang, and blow. So we're sucking in air and fuel. We're putting the squeeze on that air and fuel mixture. We're having a bang with that big controlled explosion. and then we're blowing out all the spent gases that are left. So what you need to get from this is, number one, what the names of these four components are. Number two, what is that piston doing in each of these strokes? So if you have a cylinder that develops a misfire, you've got potentially a handful of things that can cause that. If a cylinder is not producing power, maybe it's because we're not getting air and fuel in that cylinder. Maybe the valve isn't opening quite like it should, or maybe the fuel injector on that cylinder just isn't squirting fuel. Maybe it's because the spark plug on that cylinder isn't working properly. It's not getting its voltage from the coil, or maybe the spark plug is damaged. Maybe our engine has a mechanical concern where it's not generating compression, it's not generating enough cylinder pressure. The spark from the spark plug by itself will not ignite that air-fuel mixture. It has to have the compression to go along with it. Or maybe it's because our exhaust is weak and it's not allowing us to pump out all the exhaust gases, therefore we can't suck in fresh air and fuel. So being able to diagnose an engine concern is directly related to understanding how all this works. You need to be able to run that through your mind so that you're not guessing. Because guessing costs a lot of unnecessary time and a lot of unnecessary money. You don't want to put spark plugs in a car if it's not going to help it, or spark plug wires, or fuel injectors. You don't want to tear the top of the engine off if you don't have to. So there are several tests that we're going to be learning to do. We're going to be doing some compression tests. We're going to be learning about basic fuel and ignition systems so that you can test an ignition system or test a fuel system, test fuel pressure, test fuel injectors. We're going to be tearing some engines apart so that you can look at the timing of this, whether it's a timing chain or whether it's gear to gear. There's a way that you can verify if the engine is in time properly. So we're going to be looking at all that stuff. But for now, this is all the information we're going to cover for today. So I'll leave this up here. You can thumb through today's class. If you have not yet been on there, or if you haven't been on there in a while, you should see that you are now enrolled in engine repair and engine performance. So just kind of glance through that information and you're going to start to see a lot of this stuff. In engine repair, there's some very, very good pictures and videos of animated engines moving up and down so that you can see this taking place. We've also got a propane-powered engine over here that we're going to be using.